going to be going over number 23 from the sprint round. And we have that Sebastian lives on the coordinate plane at the origin, and he wants to travel to the point 5,5 in exactly 4 hours time. In the hour h, where h is between 1 and 4, Sebastian can travel a total distance of h units either up or to the right, or any combination of those two directions. In addition, every hour after h is less than or equal to 3, both coordinates of his position must be no larger than h. How many possible routes can he take to his destination? So first, let's draw a coordinate plane, and then let's mark some points that we're going to be using. So he starts off at the origin, which is right here, and he wants to get to 5,5 after 4 hours. We're also given that every hour he travels either up or to the right. So that means after 1 hour, x plus y has to be 1, since he could either go up, increasing y by 1, or to the right, increasing x by 1. So x plus 1, y equals 1 after 1 hour, and then after 2 hours, x plus y would have to be 3 after 2 hours, and then after 3 hours, x plus y would have to be 6. And let's look at the other condition, is that after hour h is less than or equal to 3, both coordinates must be no larger than h. So that means that the maximum of x and y has to be less than or equal to 1 after 1 hour, less than or equal to 2 after 2 hours, and less than or equal to 3 after 3 hours. So let's just draw those conditions on our graph here. So first, let's just, so after 1 hour, he has to be within this box here. After 2 hours, he has to be within this box. And after 3 hours, he has to be within this box. And then let's, now let's look at where he can be after 1 hour. So since x plus y is 1, the graph of that would look like that. So that means that after 1 hour, he could either be at that point or that point, which is 1, 0 or 0, 1. And then similarly, after 2 hours, x plus y equals 3. So that would look like this. So that means that there's 2 points that he could be after 2 hours. And then after 3 hours, x plus y equals 6. So that would mean there's only 1 point that he'd have to be that after 3 hours, which is 3, 3. And then finally, after 4 hours, he has to be at 5, 5. So now let's look at those points. So we started the origin, and then we either go to 1, 0 or 0, 1. Then after 2 hours, it's either 1, 2 or 2, 1. After 3 hours, he has to be at 3, 3. And after 4 hours, he has to be at 5, 5. So now we just need to count how many routes he can take to his destination. So from here, there's one way to get to 1, 0, which is just going up 1. And there's one way to get to, that was 0, 1, and this is 1, 0. And then to get to 2, 1, he can either go from here, there's one way to go there. And from here, there's 2 ways. He can either go right then up or up then right. So that'd be a total of 3 ways to get to that point. And similarly, there'd also be 3 ways to get to 2, 1, since he could there's one way to get from here and 2 ways to get from here. And then to find how many ways he can get to 3, 3, there is 3 ways from each of these points, since he can go up on the first one, the second one, or the third one. And similarly here, he can go right on the first one, second one, or third one. So that gives us a total of 3 times 3 plus 3 times 3. So 18 ways that he could reach 3, 3 after 3 hours. And then finally, in the 4th hour, he wants to go up 2 and right 2. So there are 4 choose 2 or 6 ways to get from here to here. So we just multiply 18 by 6, and we get 108 ways to reach his destination in 4 hours, which is answer choice D.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.